welcome to CP1. This is topic 7. In this topic, we are going to talk about two important algorithmic technique or paradigm. One is greedy, the other is, I call it sweeping, so because one instantiation is a sweep line algorithm. So a greedy algorithm basically means we solve an optimization problem using heuristics. So this is in contrast to searching through all possibilities and find the optimal solution. And there are different ways of doing this searching through all possibilities. One is exhaustive search, where we literally go through every possibility, sometimes using recursion, sometimes using backtracking. And the other case is we use dynamic programming, which search through all possibilities, but it avoid solving the sub-problem again and again by storing them to reuse them. And sometimes this involves the very clever designing to solve it. And greedy algorithm will only search through a subset of the solution space. And we do that by making locally optimal decisions. So when we need to do some assignment, so we just look at one and then see what's the best way to do that. And then the hope is that combining these local optimal decisions in the end will lead to the global optimal solution. And for a greedy algorithm to be correct, usually it can be proven that this is always correct. And we're going to look at those some examples of the techniques for proving it. And it's important to emphasize that a greedy algorithm doesn't always work. So sometimes you may have a heuristic that you think it should work, but there may be corner cases that the heuristic would fail. So unless you can prove it, or based on extensive experiences, you are really sure that the heuristic would work. So there's always a chance that it actually, if you use greedy algorithm, the heuristic you use may actually fail. So the sweeping technique is, in my view, related to greedy because they are all generally involved in some ordering. So, or let's just say sorting. So the way I view sweeping technique is we have many items to be processed, and then we sort them based on some order, and then we just process them in that order. And like I said earlier, one special case is a sweep line algorithm in computational geometry when we want to process objects in, let's say, 2D space. We can have a line, let's say, x equals some constant, and then we just move that line across the space and find the object that intersect with the line, and then we process them. But in this topic, we'll not use the computational geometry example. We just use other examples where we sort things and then process them one by one. So again, these two techniques, greedy and sweeping, is very much example dependent. So the only way to learn how to use them is to look at a lot of problems that they are used and then solve some problems using this technique.